Hello, algebra students. We are going to kind of pull together all of the systems work that we've done so far. We have solved systems of equations in 3 different ways. Let's review what those ways were and when you might want to choose to do a problem in a particular way. Today, what we're going to be doing for your homework and for part of the test that you'll be taking is you'll get an option for solve these systems of equations with whatever method you prefer for particular problems. So let's talk about what makes more sense in different situations. We started solving with graphing. And remember, graphing is really nice if you already have slope-intercept form, if the y is already all by itself, or if it's really easy to get the y by itself, especially if you have smaller numbers that would easily be able to be graphed. If you've got a y-intercept that would be like, let's say in the 30s, you probably don't want to try to graph that. But if you have a y-intercept of 3, that would be an easy one to graph. The second method that we used was substitution. So that's when we can take one of the equations and solve it easily for one of the variables, either the x or the y. Remember, it doesn't always have to be the x or the y. It's just whichever one is easier, and it can be from either equation. The third method that we had, and this one is my personal favorite, is elimination. Remember, elimination is when we're going to add equations together and make one of the variables go away. But for this to happen, we have to have coefficients that are opposites. It can be either the x's or the y's, but they have to be opposites so that when you add them together, they cancel out. If you don't have opposites, you can do some multiplying. Multiply by a -1 if you need to, if they're exactly the same, or multiply one or both equations by whatever numbers necessary to be able to get opposites for one of your variables. So what we have today is just these 3 problems. These are the only ones that we're going to do. I have one graph there because I would like to choose one of these to do graphing with. And it could be any of them. Remember, you could use any method for any of these, but I want to do one method or one problem with each method. So we want to practice that. If I'm looking for the one that's going to be the easiest to graph, I know in my second problem right here, I have slope-intercept form. It's perfect. It's great. In the first equation, I would end up having to do some dividing by 3, which would work. We could certainly make that work. That wouldn't be a horrible one to do with graphing. In the third problem, it wouldn't be hard to get slope-intercept form. However, if you look at this, this is going to be a y-intercept of -16. When I move this 8x, I would have y equals -8x minus 16, which isn't impossible to graph, but on our graph, it doesn't go that far. So that would be a difficulty with that problem. I'm going to choose the very first one as my graphing problem. The first equation's in slope-intercept form. The second equation is easy to get slope-intercept form. I would need to move this 2x. So I'll get that y equals 2x plus 3. Notice that's not 5x, right? The 3 doesn't have an x. They don't turn into one magic thing, right? So as long as I have my green marker in my hand, I'm going to graph this second equation first. So y equals 2x plus 3. That would start at 3 on the y-axis. And my slope is 2, or 2 over 1, which means up 2 over 1. I'm going to get as many points as I can. I have to move my graph again here. Okay, so there's my line. Some of you are not drawing the actual lines. Please make sure that you draw your line. You can use a straight edge. I can't, but get your line, not just points. The first equation was y equals -2x minus 5. So I'm going to make that a -2 over 1 for my slope. Starts at -5, -2 slope. So it starts at -5. 1, 2, 3, 4, 5 would be right here. A -2 slope, down 2 over 1. Make sure it looks like it's going downhill. It's going away from the other line. So let's reverse. Up 2, left 1. Up 2, left 1. Okay, so now I know where my lines are going to cross. That's just me being extra careful to try to get my line as accurately graphed as possible, even though that doesn't look that great. Right here is the point where they cross. That ordered pair is left 2, so -2, and then down 1, right? So -2, -1 is my solution for this problem. To check it, remember, you could substitute into either or both equations. If the y was a -1, here I would have -2 times -2 is +4. 4 minus 5, that is equal to -1. When I substitute in the second equation, -2 times -2 is going to be a +4 again. 4 plus a -1, yep, that is 3. All right, looking at the two problems that I have left, knowing that I want to do one of them with substitution, I would definitely prefer to use the second problem with substitution because I already have y equals something. If I already have that, I might as well use this and say this is what my y equals. Let's put that in place of the y. So I would have 2x plus 3, and then instead of the y, I would put in that x plus 2 equals 21. If you feel comfortable doing this one on your own, pause the video, solve this problem. Doing my distribution, I'm going to get a 3x plus 6, and these two go together, so I've got 5x plus 6 equals 21. So let's subtract the 6, and I get that 5x equals 15, and divide by 5. So the x is going to be 3. Once I know what the x is, I have to find the y, and I might as well go where it says y equals. So I'm going to use this equation right here. Y equals, instead of an x, I'm going to write in 3 plus 2 gives me 5. So the x is 3, the y is 5. And again, I could check that with the top equation. 2 times 3 would be 6. 3 times 5 would be 15, and 6 plus 15, yep, that is 21. For this last problem, if I want to do elimination, the first issue that I have is that I don't have everything all lined up. The bottom equation is kind of what we usually expect to see with the x version and the y. So let's just flip-flop these two things. I'm going to squeeze it in between here. So I would have a positive 8x plus y equals -16. Now, everything's lined up, and my y's matched exactly. I really need one of them to be a -1y instead of a +1y. I don't care which equation gets multiplied by -1. It really doesn't matter to me. It's not going to make any difference in terms of your answer when you do this. So I'm going to, I guess, let's multiply this one that we just switched around. Let's multiply this one by -1. When we distribute, remember, you're going to distribute to both of these, but also after the equal sign. That's the one that people forget. All right, so I'm going to write this new one now underneath this second equation. So I'll have -8x plus a -1y, because this was a +1y, and -1 times a -16 is +16. So -3x, -8x, that's -11x. -5 plus 16 is 11. So x is -1. Once we know what the x is, I still need to find the y. And now I don't have an easy, like, oh, look, it says y equals. So I'm going to go back to, I don't know which one, maybe this original problem before anything got changed on it. Remember, you can use original problems or the adjusted ones. That's just fine as well. So we're looking for a y. I'll have y plus 8 times -1 equals -16. So y plus a -8, and we'll add 8. So my ordered pair will be -1, -8. When I substitute back into, let's use the second equation because I just used the first equation to get that variable. -3 times a -1 would give me a +3. I know this is getting super messy right here. 3 plus -8, yep, that is equal to -5. That works. Today's worksheet is the Chapter 5 Systems Review worksheet. Be careful on there. Check your answers with the answer key in Schoology. Be ready for the test. It's going to be coming up tomorrow. When you're done with this, make sure that you take the formative in Schoology and let me know if you need any help.